A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello. We know that metals have different reactivity. We can utilize this reactivity to generate electricity. There is a cell known as galvanic cell. It's a system used to generate electricity by utilizing the difference in the reactivities of metals. So, in a galvanic cell, electricity is generated by chemical reactions where the chemical energy is converted to electrical energy. That means the conversion of chemical energy to electrical energy. Let's see how a galvanic cell should be arranged. Take 100 ml zinc sulfate solution and copper sulfate solution in 2 beakers. Place the zinc rod in the zinc sulfate solution, the copper rod in the copper sulfate solution. Connect the 2 rods with a voltmeter. Connect the negative terminal of the voltmeter to the zinc rod and the positive terminal to the copper rod. Connect both the solution in the beakers by a salt bridge. What is salt bridge? Salt bridge is a U-shaped tube filled with a paste made by mixing gelatin or agar-agar gel and a salt like potassium chloride, potassium nitrate and ammonium chloride. Do you know what is the use of it? This salt bridge completes the circuit by transfer of ions and maintains the electrical neutrality of the cell. Let's see the transfer of ions in the galvanic cell. Here, when comparing zinc and copper, zinc is the most reactive and copper is the least reactive. Who will donate the electron? Yes, zinc will donate the electron. Zinc loses its 2 electrons and become zinc 2+. What is the reaction? Zinc gives zinc 2+ plus 2 electron. Loss of electron. So, zinc undergo oxidation. The electrode at which the oxidation occurs is called anode. What is the name? Anode. Anode has negative charge in the galvanic cell. So, here anode is zinc and oxidation takes place at anode and it has a negative charge. The electrons released from the zinc rod reach the copper rod through the external circuit. The copper sulfate solution contains copper ions. We know that. And these copper ions receive electrons and become copper atoms. Let's see the reaction on the copper electrode. Cu2 plus 2 electron gives Cu. Copper ion changes to copper by accepting 2 electron. That means copper undergo reduction. So, in the galvanic cell, cathode is the electrode where the reduction takes place. So, here copper is the cathode and in galvanic cell the charge of the cathode is positive. So, here copper electrode is in positive charge. So, oxidation takes place at anode and anode has negative charge. Reduction takes place at cathode and cathode has positive charge. Then, what will be the combined equation for the reactions at 2 electrodes? In zinc rod, the reaction is zinc gives zinc 2 plus 2 electron, and the reaction in copper rod is Cu2 plus 2 electron gives Cu. When adding these two equations, there are 2 electrons in both the side of equation and we can cancel them, and the net equation is zinc plus Cu2 plus gives Zn2 plus Cu. Zinc plus copper ion gives zinc ion plus copper. So, this is the net reaction happens in the galvanic cell. This is a redox reaction. Why? Both oxidation and reduction takes place simultaneously, and that type of reaction is redox reaction. So, in galvanic cell, electron transfer takes place by redox reaction and which causes the flow of electric current in the cell. Then, what is the direction of electron flow? The direction of electron flow is from the anode to the cathode. That means from the active metal to the less active metal. Okay. So, do you understand what a galvanic cell is? A galvanic cell, or another name voltaic cell, is an arrangement in which the chemical energy is converted to electrical energy through redox reaction. Okay. So, this is galvanic cell. There are some another cells also utilizes the change in reactivity of metals. Let's study about them later. Bye bye.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.